Alright, sweet. Next video. Reverse shells. We're going to focus on some difficult ones. So Alpine and Docker Scratch, if you've ever played with that. Literally, it is a single layer container. Really difficult to compromise, so we'll get an idea what we can do there. We'll go ahead and reverse engineer it, and then we'll actually upload a couple tools to see what we can do. We're also going to take advantage of our Caldera C2 we made in the last video. So let's go ahead and get started. Actually, we probably should pull up a couple repos. So let me go ahead and pull these up. Let's bring you back over here. Okay, so we're going to need our repos, and we're going to grab standalone and standalone. So reverse shell has been updated, and standalone bash. We're basically building bash from source. So we're going to use Kali. This is the Windows subsystem for Linux, as well as the Ubuntu version. Where'd you go? There you are. Okay, cool. So let's go ahead and get over to, let's start with standalone bash. Okay. Some of this is going to be hidden. I'll make sure these commands show up though. Okay, so let's do, we're going to use screen so we can jump between different windows using the same terminal. So let's go ahead and do that. X, we'll do, oh wait, not X, we'll do standalone bash. Okay. What we'll do is we'll go ahead and build it. Okay. Went too far. Let's go ahead and build this one. Okay, let's go ahead and build this. I have to be aware of my short keys because I just blew up my camera. So we'll go ahead and build this. And while that's building, we're going to hop out of here. Okay. Reset, screen-ls. Okay. And while that's building, we'll go ahead and go over to our standalone reverse shells. So let's start with Debian. What we do here is we have a C# file, or sorry, C# program using .NET. We're going to go ahead and build reverse shell. We're going to use the Kali IP since that'll be our listener here. So let's go ahead and open that up. Okay, cool. So cat docker file. You'll notice that, actually, hang on. You'll notice that we use .NET to publish this, and it's supposed to be a single file and contained true. So in theory, this should be a completely standalone binary that's built. Too far again. Okay. I'm actually just going to label this something different to help me out. Docker build -t standalone rev shell deb C#. Actually, let's not do that. I need to do this in screen. Yeah. Exactly one argument. Did I not do that? Try this again. Oh, you know what it's doing. I think it's the wraparound. That's exactly what's going on. Build -t standalone rev shell deb C#. All right, go ahead and let that complete. Screen -ls. So let's see if bash is done. Docker images. Okay, as you can see, it's there. So we're good to close this out. Actually, let's do this. Let's swap you guys around. There we go. Makes it easier so you guys can see what I'm doing. Okay, cool. So now that that's done, let's get over to our Alpine build. And in this case, we're going to use Golang. We cat the shell. Oh, I've already got that updated. Cool. So very, very simple TCP reverse shell. Plain text, same as the C# for Debian. Let's go ahead and build it. As you can see, though, the exec command is ash because Alpine uses ash, not bash or zsh. So we'll go ahead and do this. If we cat the Docker file, you can see it just literally go build shell.go. Okay, let's check screen. Let's do standalone. Golang Alpine. Okay, cool. So if we cat, I guess we don't need to cat the readme. Just do a docker build -t standalone rev shell. Let's say Alpine, Golang, and that should be good. Okay. Oh. Screen-ls. Let's go see how this one's doing. Okay, it's done. So let's jump out of there. And while we're waiting on that, let me show you the Scratch image. Notice there's a lot more going on here. I'm going to remove bash, and I'm going to remove shell. Okay, we have two Docker files here. Why? We're going to build the Golang a little bit different, just due to the way we're going to add bash and the Docker file. So if we cat Docker file, so typically you'd only have from scratch, copy your binary, and then command. In this case, we're running two because I want to show something off. Actually, before we do that, let's hurry and reverse engineer it so you get an idea of what's under the hood. So we're going to do, we're just going to comment this out. Docker build -t. We don't have bash here yet. We'll come back to this because I want to show you what it looks like when we save it and then start looking around. Okay, let's go ahead and grab screen. I'll just do ls. Okay. Make sure this is done. Okay, that's done. So Docker images. Okay, we've got everything we need. So we're going to copy these over just so we can use them. So we're going to do docker run. Or actually do this in screen because I need to copy them out. You can't copy container to container, or at least not yet that I'm aware of. Screen -s. And we'll say docker copy bash. Docker images. Docker run -rmt. Okay, so we can see we're in the bash directory, and if we ls bash, actually, you can see 5.2 megabytes. So it's a beefy file, but it is standalone, so it's to be expected. So I need to copy this. Clear docker container ls. So that's it. So we're going to do docker copy, paste that so I don't lose it. Okay, there's our container ID. We want bash, and we want it right here. There it is. You can run checksums, but I'm confident it's all there. So let's do -ls. Screen. Exit. Exit. Okay, we got that done. Now we need... Let's take a look at this one real quick since we're here. Docker run rm it. Basically it's saying once this container stops, get rid of it completely. I don't want to ever see it again. IT interactive. We want to interact with this container. So we're going to grab C#. I think that's enough. Yeah. So ls. We have to find it. Bin all the way here. I want to say it's in publish and network. Yeah, it's right there. So this is our standalone file. You can see it's 64 megabytes in size. It should be standalone. However, there is a whole lot of linking going on here. So not confident it's going to do what I want it to do without modifying the host operating system. But I mean, if you are able to install packages on the host, that means you're running as root. And if you're root, you can do what you want. In a container situation, you might have to copy binaries over. Or maybe you can actually, if let's say the pod is deployed, or sorry, container pod deployed with capabilities, you might even be able to escape to host, depending on how much you can mess with the kernel, just because the way pods share the kernel with the host operating system. But in this case, this is bad, because you can see all these things are linked. If I was to copy this onto, I mean, Alpine, you're screwed, because if Alpine doesn't have any type of GCC or muscle, it's not going to work. And then there's the ICU libs, so that'll get messy real fast, but in theory this should work on another Debian, and we can actually test that out. Yeah, let's go ahead and do that. Okay, yeah, let's go and do that. So let's do screen -s. We'll do standalone rev shell Debian. Okay, Docker pull Debian latest. Make sure I spelled that right. There we go. Okay, and then what we'll do is we will run it. Okay, now let's make sure we're in root. Okay. Damn it. Clear. Okay. So screen -ls. We have that. Docker images. So we're going to need to grab this one right here. And what we're going to need to do is open one more session so we can copy the file out. So we'll do screen -s. Let's do deb rev, I don't know, deb C# copy out. Okay, good. Docker run -it. Paste that. ls bin publish network. That's the file we need. So we're going to copy that. We're going to opt network, so let's remember that. Here, Docker container ls. Okay, so let's do copy. We need opt network that. And the container ID, that guy. So in theory, this should be here. Oh, ropt. Okay, that's one hell of a typo. There we go. Network. So if we do LDD network, we can see at least this operating system has everything that we need, but I mean, this is my dev environment, so of course that shit's going to exist. Let's copy it over. Docker container ls. There's latest, so we're going to do Docker cp network, and we're going to do this guy, this container ID over to root. Okay, -ls, and we want standalone, this guy right here. Screen -x. Okay, we're here. The file is here. LDD network should exist. So if we do a netcat LDNP 9001, this should work. Ooh, it aborted. Why? Couldn't find our ICU libs. So in this case, if you had a low-level shell, you're hosed. You're not going to be able to use this. If we're here as root, we could probably install it. So if we do an apt update, apt install. Okay, well, this is fun. Apt search. Oh, okay, I was close. Dev. 174 megabytes. So as you can see, if this is low-level user shell, you're hosed. You have missing dependencies. So let's see if that works. Hey, look at that. Who am I? Root. Hostname. And yeah, so as you can see, that worked. Okay. So let's exit out. And remember, this was just a Debian latest. Yeah. Okay. Clear. Let's see what we got. Copy out. Did we get that? We did. Okay. So let's hurry and drop this because we're done with it. Exit. Exit. Clear. ls. Let's remove that network file. Okay, so let's try the Alpine one. So if we go to Docker images, let's grab this one right here. And remember, this one's going to be running Ash because that's how Alpine works. Let's actually do a Docker poll Alpine latest, just so we can get that image. There it is. And just for fun, we'll pull in 3.18. Okay, cool. So those all exist. Let's do a screen -s. Actually, that's not a bad idea. Okay. Docker run -rmit that. Okay, we're an opt. And you can see shell. So let's do a quick check on our dependency libraries. Shell. Not a valid dynamic program. That means LD muscle, we were able to compress or get everything built into one static binary. Should be a beefy one too. 2.4 megabytes. That's not too bad. We could probably get that lower using like UPX, the packer. I'll show you what that looks like in a second. Anyways, not bad. So let's go ahead and jump over here and copy it out. Docker, if I could spell, container ls. Let's grab that one. Docker, copy this one out. Opt, shell, here. Okay. Now what we're going to do is we're going to shell s. Ah, shit, come on. Exit out of here. We can do that. Docker run --rmit, and we're going to do Alpine latest. So right now we're root, very generic container. We don't have all those fancy ICU libs and all that installed. Okay, cd over to root. Okay, we have our shell, Docker container ls. Docker cp, so copy shell over to this guy, and we'll dump it into root. Okay. This should still exist. It does. So shell. So let's set up our netcat listener. Does it work? Hey, look at that. Who am I? Env maybe. Oops. Env. Oh my god. Env. There we go. So as you can see, like even with those errors, we have Ash, right? So, I mean, at this point, I didn't have to install any dependencies. It's all there, ready to go, right? Great. Okay, let's go and exit out of here. Exit out of here. clear this up. Docker images. Cool. Now we know how that shit works. That's how you get a reverse shell on Alpine latest, right? With just a single binary, just a simple Go reverse shell, and you can get it from these. This guy right here, standalone bash. That's for standalone bash, and this guy for the reverse shell. If you go into Linux and if you go into Alpine, they're here. Also with Debian, they do have the C# stuff. I'm leaving it there. You could just use the Alpine stuff and switch it from Ash to Bash, but we could probably just change it. I can add that later, but the reason why I left it here is because I want a C# option, right? Okay, cool. So standalone reverse shells. Let's go back here. Now what we're going to do is we're going to create a Scratch image and show you how castrated those things are. So if we cat the Docker file, we're only going to copy bash, and I think I have bash here. Cool. So let's build it. Let's do docker build -t scratch just bash dot. Okay, as you can see, that was pretty fast. We got one layer in. So if we do docker images scratch, let's do this. Docker save, what is it, .tar? Oops, that's right. Dash O. Okay, so we look at this, make directory temp, move scratch to temp, cd temp. Okay, we're gonna file scratch, what is it, tar archive tar xdf, I think that's right. Yeah, there we go. So we've decompressed all this so we can take a look at what the hell is under the hood. Let's cat the manifest. Do we have JQ? No. Okay, sudo apt install JQ. We want a pretty print JSON. So let's go ahead and JQ dot, okay. Config, repo, layers. Pretty handy, right? Let's cat repos. JQ, latest, great, okay. Let's cat this really long string over here, JQ, this should give us a little bit more. Okay, cool. So we see our environment, we see the command being ran, working directory, root. I mean, really simple shit, but this is super important when you need to reverse engineer something. If I want to break something, I want to know how it works. If I know how it works, I'm going to be more successful when I go to compromise it, right? So we know all that's in here is bash. Well, if that's true and we run it, we're going to get a bash prompt, which is kind of unheard of in Scratch. Can we even use it? Let's jump into that. Docker images. If I could do that. Docker run -shrmit just bash. Okay, let's start using commands. Env ls pwd cat. Okay, so if we hit our tab a couple times, we see what commands are available. Couple cool tricks I can show you. So let's first start with the root directory. That's what's there. Well, let's go to cat docker end. Okay, that doesn't help us. There's a cool trick. We do have echo. We also can pipe output of files, and we don't even have to echo it, but you'll throw an error. So let's echo it. Let's do echo /docker env. Nothing in there. Great. So let's start here. We could cat out the bash, but that's all binary and it's going to blow up our terminal. Probably should do it just to prove it. But let's go down the file system. Anything useful? Alright, I'm confident that's going to be a binary, but let's see what happens when we cat it or echo it. Oh god, yeah. So, as you can see, that sucks. Okay, so that is a scratch under the hood, right? One layer, that's all that's there. Very, very, very generic, basic, right? So trying to compromise that, you're kind of hosed. Unless you can get other tools on board. The way I see compromising a pod or a container running Docker Scratch is it's going to be your middleman. like your pivot into other resources. So let's say you have a Lambda, AWS Lambda or something that's running a simple thing of code. You would compromise that to pivot into a database or pivot into another resource. Especially with the whole sidecar proxying thing going on in Kubernetes, you're going to have to find a way of who cares about this pod? How can I use it as a pivot to get to where I want to go? And that's where like generic or unique IDs come in. Maybe I'll get a lab set up on that. But for right now, let's show you what it looks like once we actually get like a reverse shell on it, because it's going to be even more like disgusting. You won't have that tab completion and all that fun stuff. So let's cd out of here. Rf temp. We've got a shell, bash. We need to get netcat. Okay. Cat golang. So basically what we're going to do is make our shell into a binary through Go, and we'll have to copy it out. So remove shell. We're going to do docker build -t scratch golang rev shell -f, and we're going to call this golang. Well, that is the file, and then just pin it. So the tag will be that name right there. Or sorry, not build, scratch golang. Okay. So everything's done. Docker images, screen -ls. We need to copy this out now. So we're going to do screen s golang scratch build rev shell docker run. That should be enough to get it there. It is ldd shell. Again, muscle. I wonder if that'll work. If not, we'll have to build it on Debian or something. I can't really tell what Scratch is. I'm sure it's probably under Etsy, you'd think. We'll have to go back and find that out. Okay, so clear docker container ls. Docker copy this opt shell. Okay, it's there. So now what we can do is that docker, oh god, screen -x, go here, exit, clear. Okay, so now we're going to build this Scratch image right after I update the Docker file. We're going to make it 2 layers deep. Okay, we're going to docker build Scratch demo that. Okay, docker images, that's right. Okay, -s scratch test go. Okay, docker images, docker run. And if I remember right, this is going to pull the bash binary. Yeah, let's do that. It that bash. Okay, so if we do root directory, we can see shell exists. So in theory, there is no bash. Command not found, but there is a bash command, right? There is no sh, there is no zsh, there is no ash. Etsy, there's nothing in Etsy. Okay, so yeah, this is very generic. Anyways, let's go ahead and kick off that reverse shell and see what happens. Let's do shell. Hey, look at that. Who am I? Not much we can do here. ls. No tab completion. So you can see this is not much we can do here. We can do, like, if you script out maybe Docker things, we might be able to use those. So maybe shell. I don't even know if those are on here. We'll look in a minute. What about env? What about path? Oh, there's a path. And then what we could do here is we could literally just do like no such file or directory. I mean, it's obvious. There's not much here we can run with. But this is useful so we can get an idea of, you know, how to compromise Scratch. In reality, you really can't. You'd have to compromise the binary that's on the Scratch container. Okay, so that's all useful, fine dandy, whatever. But what about C2? What can we do there? There's a few options, right? Let's start with, okay, Scratch test. We're attached to it. Go ahead and exit out. Clear. Okay, so what we're going to do is we're going to pull up a few different containers. We're going to do screen-s. Let's do Alpine, Docker run -it, Alpine, latest. Okay. Now we're going to do one for Debian. Okay. And we're going to do Docker run rmit Debian latest. Okay, so now we're there. Clear screen ls. Okay, so going back to our C2. Where's my C2? We're going to use Caldera. We're going to configure the agent, and you can see avoid logs. Let's take a look at that. Oh, I've already got loaded. Okay, cool. So, not Darwin, Linux. We're going to blow out the bash history and unset history file. Basically, we don't want to log what we're doing. Great. Let's go to agents. Let's deploy an agent. We're going to do Sandcat. It is a Golang binary, and we're going to do Linux. We do need to update the host. So we're going to take this information, drop it over here. Remember to get rid of that /. It will bite you in the ass. It's gotten me multiple times. So we could change this. We're just going to use Splunkd as default, but we could change what that'll look like. Let's copy this. Let's go ahead and dump it right here. But the thing is, I don't want to run it. I just want to download it. So in theory, this should download. It did not. As you can see, Splunkd. Why didn't it download? Well, I can tell you right now. When you curl, that self-signed certificate will bite you in the ass every time. So we just need to add a -k to ignore that, and it's working. ls-alh Splunkd 5.7 megabytes. The important part to remember here is the Splunkd options. So if I do a Splunkd-h, we have multiple options. Super important to remember. But in this case, all we care about is running this on the containers for right now. So what I am going to do is I'm going to copy this. Okay, cool. ls. Ah, shit. 189. Okay, cool. So let's do this. Ooh, damn it. Well, that sucks. 8. Oh my god, I can't remember what I did. So we did Debian, now we need to do Alpine. 7. Okay. Now, we've lost everything. Hopefully it's still here. Oh, it is. Okay, cool. We need this command right here. So it's basically setting the server of, hey, here's our server, port, whatever, group, red, because we're running a red team. Well, actually, we can look at the help menu. Show that real quick. We just looked at it, but, you know. Oh, shit. No, damn it. I think it just compromised. Hang on. -h. No, it didn't, because I didn't have the server set. That's fine. Okay. Where is red? Okay, it doesn't say that. Does it? I don't see it here immediately, so we'll have to go look at documentation. But I assume it's because we're not logged in as blue, we're logged in as red. Or at least we're doing the red team side of the engagement. And actually, it should tell us right here. If we go down to blue team instead of red, so yeah, group blue. Kind of obvious, right? Oh, group. Hang on. Attach a group to this agent, default red. Okay, so that's just like, sounds like maintaining, like, I guess, categorizing and making sure you're running your red team stuff on the red team side of the house. We can obviously go look at documentation, but to me that just makes sense. Okay, cool. Let's go ahead and do I have this saved? I do. Okay, so -x, go to Alpine. Let's do this. Splunk D not found. Oh yeah, we gotta copy it over. Sorry. Clear ls docker container ls-a. No, just that. Okay, docker copy. Now, if this was a compromised host, you'd obviously be uploading this in a different method, right? Especially with obfuscation, and hopefully you've wiped out any kind of antivirus or EDR. But anyways, we're not going into that right now. So let's do this. Root Splunk D. Okay. 078. And this one. Okay. What we're going to do is we're going to grab this one more time. -x alpine ls. Okay, try that again. Send it. We've got a beacon. Should have a beacon. Do we have a beacon? We do have a beacon. And now we can do fun things with this, but we will get to that in a second. Okay. Clear dash -x. We want Debian ls. Let's not do that again. And we have a beacon. Hey, we do. Okay. Let's go back out of here. We have both beacons. Great. So now let's see if this actually works, because remember we're on Alpine and Debian. So let's go over to, I don't have an adversary set up, I don't think. So let's create a new one. We'll just call him Reaper, create. Okay, that's the adversary profile. Let's do operations, create operation. Do we have Reaper in here? Reaper, we do, because we just created that adversary. Obviously, we want to store more in this. We'd go into that adversary and create the whole kill chain, and then we'd be able to reuse it, right? But for right now, I want to do it manually. So as you can see, we got shit going on. So let's start here. We're going to go through a shell, and we're going to do a who am I, if I could spell, and we'll do this container, and we'll add the command. So that's on that host. We're going to do another manual command. And we're going to do it on this guy, shell, who am I, add command. And if we go look at our beacons, beacon alive, I mean, eventually these will run through. It just depends on how fast it phones home. Submitting results. View command. View command. It is taking its sweet time. Hey, look at that. View command. Oh, view output, sorry. Root. So both commands ran. That means Alpine Ash, and that means Debian Bash. Both ran how we expected. And then obviously we can just go back here. If we're done, we can just clean up. So right now, can we stop this? Yeah, we can. Stop it. Rerun operation. We can reuse it. Right now, as you can tell, we're doing this over SSL, or sorry, encrypted connection, HTTPS. I'm curious. Where is our security? Can I zoom in on this so everybody else can see it? Certificate missing. So it is TLS 1.3, all served securely, but the certificate is complete shit. So Let's Encrypt is useful here using a real domain. Like, obviously this is just like something I threw together. If you found a domain that has a good history that you can buy for cheap, why not? Anyways, not going down that road. Now let's go into agents, and we can go ahead and jump in here, kill it, and then we just wait. It's alive. That's odd. Oh wait, shit. Terminating, it's gone. And terminating, it's gone. So, oh shit. Sorry, exit, -ls, container ls -a, cool. So that's everything. Hopefully that's helpful. I hope that helps you also understand why it's smart to reverse engineer what you're trying to kill, or sorry, to attack. Depending on what the end goal is, maybe you want to do threat emulation. Highly recommend Caldera. There's a lot of abilities right out of the box. On top of it, I really love like, where's it at? Is it Compass? Yeah, you can get like the MITRE ATT&CK kill chain in here, Cradle Layer, export it, import it, whatever. I want to say there is. Okay, these are just abilities, access. Hang on, where are we at? It's not that guy. Is it debrief? This is our operation. Oh, well, I already screwed it up. But anyways, you get this nice little attack map that shows you how you're able to compromise it. Yeah, that sucks. I wish I had looked at that. Anyways, these are the fun parts of reverse engineering, how to get a shell on Alpine and Scratch. Hopefully this helps. If you have any questions, feel free to reach out. Thanks.